Hi, I'm Ms. Boom. Let's have a look at limits. What are limits? Now let's have a look at this graph here. What happens when x approaches 3? Well, we can see there's like a little hole in our graph, but we can predict from looking at how the graph is moving towards 3 that the y value is going to be 1. And we can see from the other side of the graph that when x goes from 5 or closer to 3, then our y value goes from 3 to closer to 1. So we can predict that y should have been 1 even though it doesn't exist. What about this graph? Well, when x approaches 3 from this side, we can see the y value is getting close to 2, but from the right side, the y value is going to be 1. So as x approaches 3 for this graph, we don't know what the y value is. And for this graph over here, again, it's two different lines, but from the left side, we can see that as x approaches 3, we can see y is going from 3 to closer and closer to 2. And from the right side, as x approaches 3, so 6, 5, 4, 3, then the y value is going to be 2. So even though these two graphs don't actually have a coordinate or a point at 3, we can see that the y value is approaching or getting close to that value there. That number that the y value is approaching, so see, as x goes to 2.5, 2.9, 2.99999, we can see that the y values here is getting closer to 0.999, 0.99999. So we're getting really close to 1. So this value 1 here is not a number that the graph is part of, but the graph is approaching as x approaches 3. So we call these values the limits. So limits is a number that we don't actually touch, but we get really close to, and we predict that that would be the number, or that it would be if a number existed there. So it doesn't exist, but we get really close to. So we say that it approaches that value. So a limit is the value that a function approaches as the x approaches some other value. So for this graph, the limit of the function x squared over 9 as x approaches 3, see, as x approaches 3, we said it was 1. So the limit of x squared over 9 as x approaches 3 is 1. So the 1 is not part of our graph, but we're approaching it. So these are called limits. So 1 is the limit. X squared over 9 is the function, and x approaching 3 is where the x value of where we are evaluating our limit. Limits are useful for when things cannot be worked out directly. Here we have an equation, an expression, x squared minus 1 over x minus 1. And we know that if y equals this, or the function of this, that the x value cannot exist at x equals 1, because when x is 1, the denominator is 0. When the denominator is 0, we cannot divide by 0, so this doesn't work. This graph actually looks like that. So see, at x equals 1, we have a hole in our graph. It doesn't exist. So how can we see that the limit is approaching a value? We can see from the graph it's 2, but how can we actually how can you actually understand that? So we can say that we can pick different values that are closer and closer to 1. So for example, we can pick x equals 0.5 and figure out what our value is, y value is, which is 1.5. We pick a number even closer, 0.9, and we can see that the y value is 1.9. And we can go even closer, 0.99. Imagine I'm zooming in and getting really close to this 1. And then our y value for that point is 1.99. If we went even closer and closer, like 0.99999, when getting really close to 1, we can see that we're getting really close to 1.9999, really close to 2. So we can see that as x is getting closer to 1, that y value is getting closer to 2. Now, what is this little negative value here? This negative here means as x is approaching 1 from the left side, so from the negative side, then we're getting closer to 2. So how would we evaluate or figure out what y is as x is approaching 1 from the right side. What would that look like? So from the right side, we would pick numbers on the right side. So for example, 1.5, and we can see that the y value is 2.5. We get closer, so 1.1, we can see that the y value is 2.1. We get even closer, 1.01, 1.001, 1 point. So we're getting really close to the 1, and we can see that as we get closer to the 1, our y value is coming closer to 2. So as x is approaching 1 from the positive side, we see that the y is approaching 2. How do we read this? As x is approaching 1 from the left, the limit approaches 2. As x approaches 1 from the right, the limit is also 2. When the left limit and the right limit exist, then we do have a limit. In contrast, we can see from the graph before that the limit on the left and the right doesn't match. We can visually see it. So let's use words to describe this. The limit as x approaches 3 from the left is 2, but the limit as x approaches from the right, as x approaches 3 from the right, is 1. So we can see the left side doesn't match the right side, so there is actually no limit at 3. There is no one value that we're approaching as x approaches 3. So 2 is not equal to 1, so the left limit is not the same as the right limit, and therefore the limit of x approaching 3 doesn't exist for this graph. So for the previous graph, we saw that the left side and the right sides does match up to the same value. They both approach, as they approach 1 from the left, and as it approaches 1 from the right, the y value both approaches 2. So the limit of the left limit and the right limit are the same. So therefore we have a limit of x approaching 1, which is 2. So recap, you always check the left and right, and if it matches, then you have a limit. If the left and the right doesn't match, then you don't have a limit. And a limit is a number or a y value that we're approaching, but we never actually have, like a hole. We can have a value there, but a limit is when we get really close to it. That's what it means. Let's look at a value that we know doesn't exist, but we use to describe things, infinity. So infinity we will never quite get there, and so 1 over infinity doesn't really exist either. But what would it be if it did exist? So let's find the limit of it. So let's pick random numbers that get closer and closer to infinity to see what 1 over infinity would look like. So let's pick 1, for instance. 1 over 1 will be 1, 2. 1 over 2 would be a half. So I'm picking numbers that are getting bigger and bigger to see what 1 over a big number will look like. 10 would be 1 over 10 would be 0.1. 100, 1 over 100 would be 0.01. 100,000, 1 over that will be really tiny. So we can say that as x approaches infinity, that y approaches 0. Or we can read it as the limit of the limit of 1 over x as x approaches infinity is 0. So that's a limit, a number that we don't have to actually touch, but we get really close to. That's it for me today. Revise what limits are. So as x approaches something, the limit is what y approaches. And I'll see you next time. Bye.